Welcome to the project management course. This is Upender working as an assistant professor in the Department of Civil Engineering in Andhra Engineering College. Today I would like to explain about project scheduling. From this course, what is meant by the project scheduling? It is the process of organizing, managing and outlining the task, activities, timelines and resources required to complete a project successfully. Every project before starting to definitely to schedule the project. It helpful for to complete the project within the time constraints and cost constraints. It means it is the process of organizing, managing and outline the task, activities and the resources required to complete a project successfully. And it involves creating a detailed plan that specifies what needs to be done, when it needs to be done, who will do it and what resources will be used. In simple terms, it's like creating a timetable or a roadmap. So project scheduling is nothing but a roadmap for a project to ensure everything gets done on time and within the budget. What are the key elements required to scheduling, or what are the key elements including in the project scheduling? The following key elements involved in project scheduling, they are task identification and sequencing, time estimation for each task, resource allocation, milestone settings, deadline and dependence. In that first key element is the task identification and sequencing. It means first of all to clearly identify the project objective. Let us know briefly about task identification. Before anything can be scheduled, you need to know what work needs to be done. This involves breaking down the project into smaller manageable tasks or activities. This is often done by using a work breakdown structure, means WBS. Work breakdown structure. It means, for example, laying of the foundation. Laying of the foundation is one of the activity in the construction of the building. Here, the foundation work is breakdown into small structures like clearing of the site, marking of the site according to the position of the columns. Then excavation work is started. After that, laying of the foundation. And then arranging the activities in sequence. We are sequencing the task or activities in the order. They need to be completed based on logical dependence. For example, you cannot paint a wall until it's built. It clearly shows the sequence of the activities. It means when the completion of the wall, after that paint is possible. And here to determine the dependencies also in the task identification and sequences. Here the main tools used for the task identification is network diagrams like PUT and CPM. PUT means project evaluation reviews techniques and CPM means critical path method. And activities list also helpful for the tool. It is activities list tool helpful for the task identification. And then second one is the time estimation. Once the activities are identified and then arranging the sequence, activities are all arranged into sequence, and each and every task or activity takes how much time to calculate with the help of the PUT, project evaluation review technique method. And some common estimation techniques are there. They are the analogous analogous estimation, 3-point estimation, resource allocation methods, milestone settings, deadline and dependence, etc. So let us know more about time estimation. Once tasks are identified, the next step is to estimate the time required to complete each task. This includes considering the complexity of the task and availability and skill level of team members. Here the external factors like weather or supplier delays. Common estimation techniques are including analogous estimation. Here analogous estimation in this 3-point estimation and goals. 3-point estimation means optimistic time, pessimistic time, most likely time. It means the PUT. Here the time is estimated with the help of the optimistic, pessimistic and most likely times. Like T is equal to O plus 4M plus P by 6. This formula is used to calculate the time required for each and every task or activity. The third one is the resource allocation. Resource allocation means after the identification of the task, the time estimation after time estimation, then resources allocate. What are the materials required and how many people required to complete the task, and what are the equipments required to complete the task, and to arrange all the resources and arrange and adjust to the activity or task. This involves assigning the right people, tools, equipment and materials to each task. Important aspects including identify who is responsible for each task, checking availability of resources, checking availability of the resources and leveling resources, which means adjusting the schedule to avoid overloading people or equipment. Then what are the tools used for resource allocations, like resource histograms and resource calendars and responsibility assignment metrics like RACI charts, helpful for the resource allocation, and what are the resources available and what are the resources required to complete the project. All are identified with the help of RACI charts. And then milestone settings. Milestones are the key points in the project timelines that signifies the completion of the major task or phases. They help in tracking progress, highlighting critical achievements, communicating important deadlines to stakeholders. Example of the milestones: completion of the design phase, launch of a prototype, final project delivery. Milestones have no duration, they just mark important events. And deadlines and dependencies. Every task has a start and end date. Scheduling also involves identifying dependencies, which are relationship between tasks. Dependencies like finish to start, start to finish, start to start, finish to finish, start to finish. These are the dependencies identified in this deadline and dependencies. So in that first one, finish to start, the task B, for example, the task B cannot be start until task A finishes. For example, task B cannot start until task A finishes. Like earthwork completion, after that foundation is laying. Finish to start means site work, completion of the site clearance, then marking of the columns. Start to start, task B can start once task A starts. task B can start once task A starts. Then third one, finish to finish. Task B finishes when task A finishes. And then last one, start to finish. It is a rare case, but task B cannot finish until task A starts. This helps determine the critical path. Critical path means longest sequence of dependent tasks that defines the shortest time in which the project can be completed. A goal of deadline and dependencies is ensure the scheduling is realistic and considering all necessary task relationships. And then monitoring and control. Once the schedule is set, it must be traced and updated regularly. This includes measuring actual performance against the planned schedule, adjusting the schedule if delays or changes occurs, communicating updates to the team and stakeholders. And tools used: Gantt chart, project dashboards, end value analysis, like elements and purpose. Here the table denotes the elements in first column and purpose is in second column. The task identification and sequence, the purpose is know what to do and in what order. Time estimation, know how long each task will take. Resource allocation, assign the right peoples and tools. Milestone settings, track progress with key checkpoints. Deadlines and dependencies, organize timing and task relationships. Monitoring and control, the main purpose is to keep the project on schedule. And then critical path method. It is a short form is the CPM. It is a project management technique used to determine the longest sequence of dependent task. Means critical path. It is helpful for identifying the critical path that must be completed on time for the entire project to be finished on schedule. In simple terms, it helps identifying which tasks are most important, the minimum time needed to complete the entire project with the help of the critical path method. It is also called as a critical path analysis. Critical path analysis is commonly used with all forms of projects including construction, aerospace and defense, software development, engineering and plant maintenance. And critical path was used first time in 1966 for major skyscraper development of the constructing the former World Trade Center, means Twin Towers in New York City. The two phases required for calculation of the CPM, they are ES means earliest starting time and latest completion time. Here ES means the forward phase and LC means the backward phase. To determine the earliest starting time with the help of this following formula, ESJ means earliest starting time at node 2 is equal to maximum of ESI plus duration. DIJ means duration, ESI means earliest starting time at the starting node. Means for example, it is a node 1, it is a node 2. To determine the earliest starting time at the node 2 with the help of, where node 1 is the known value is there, here to submit the known value and duration, how many days to required to complete that activity from 1 to 2. Here 2 is not known. To determine the value of 2 with the help of this earliest starting time at node 2, ESJ is equal to maximum of ESI plus duration. And to determine the latest completion time means backward phase, it is the second and 1. To determine the latest completion time at the first node, Here the second node value is known and first node value is not known. To determine the value at the first node with the help of LCI is equal minimum of LCJ minus duration. Here duration is known value and J is known value, and here I is the unknown value. This formula is used to determine the unknown value of the first node. The conditions for critical path is ESI is equal to LCI. ESI means earliest starting time at the first node is equal to the latest completion at the node 1. Earliest starting time at node 2 is equal to latest completion time at node 2. This condition fulfills the path, that path is called as a critical path. And third case is earliest starting time at node 2 minus earliest starting at node 1 is equal to latest completion at node 2 minus latest completion at the first node is equal to duration. These two conditions is equal to duration is called as critical path. This is the example problem on the critical path. In that problem, the activity and durations are given to determine the earliest starting time, latest completion time, and to check the following conditions, and free floats and total floats helpful for the identification of the critical path. When the free float and total floats are zeros, that path is called as critical path. Thank you.